Hi guys, I hope you had a good weekend. So we are starting into the next section, which is on inverse functions and inverse trig functions. Okay, so first I'm going to do a review of just straight algebraic inverse functions. Okay, so from algebra 2. So we can find the inverse by switching x and y. So for example, here we're just given some ordered pairs. So if I switch the x and y, my inverse would be 2, 1, negative 2, 6, negative 3, 2, So is the original a function? So the way you can check for this is if you see any x's repeat, it is not a function. So all of my x's in the original are different, so yes, it would be a function. So no x values repeat. Now to see, oh, sorry, go back 1 second. And another way, if you had a graph of this, you could use the vertical line test. So for example, total side note, if I had a graph that looked like this, that would pass the vertical line test, so it's a function. If I had a graph that looks like this, that would fail the vertical line test. So that would not be a function. Okay? So to see if an inverse is a function, okay, you want to once again see if any of the x values repeat in the inverse. So if you notice here, 2 repeats. So no, the inverse is not a function. The reason there is because an x value repeats. I also think about this. If you go back to the original, if you would plot those points, you would see that it fails the horizontal line test. I will abbreviate this like so and this like so. Okay? All right, so the formal definition, you have a function f of x and g of x. They are inverses if and only if when you compose them. So f of g of x comes out to x, and g of f of x, when you compose those, it comes out to x. A lot of times kids say, well, if it works one way, won't it definitely work the other way? Most of the time, but there are some obscure rando functions out there that it works one way and it doesn't the other. So you should definitely check it both ways. So let's verify that these two are indeed inverses. So first I'm going to start with f of g of x. Okay, so that means I am going to take g and plug it in for every x in f. And if it comes out to x, they're inverses. So let's distribute that in. I get x plus 4 minus 4. Those 4's cancel. Oh, it comes out to x. Great. Now let's try it the other way. G of f of x. So now I'm going to take the f function and plug it in for every x in the g. So distribute that. Those two cancel. Oh, fabulous. So those are indeed inverses. Right? And this is how you, if you ever see the word to verify that they're inverses, this is how you would do it. Okay. So it says find the inverse. Now notice this is the same thing as above. Just a heads up, it's the same function from above. But I'm going to go through how you actually find that inverse. Okay? So I'm going to call this kind of like part A, part B, and then part C. Okay, so to find the inverse, I'm going to turn f of x into y. Now what we do is we switch x and y. Okay? And then you are going to solve for y. Okay, so add the 4, divide by 2, and I'm going to rewrite this. So this is the notation for inverse, just to refresh your memory. So the inverse is x over 2 plus 2, or you could also write 1/2 x plus 2, same difference. Okay, so you generally do want to rewrite it so you have y now as the inverse of x. So part B, let's graph these. So I'm going to graph, this is just a super rough sketch, so graph the original. Sorry about that. Hold on. Okay, so this is my original. And now I'm going to graph the inverse as well. Something like that. Okay, now something else that you should remember, okay, is that they should, if they are indeed inverses, they should reflect across the line y equals x. If I draw in this dashed line, they should reflect across that line. Okay, now part C, where it says to verify the inverses, we just did that in the last slide. So I'm not going to redo that. So if you ever see the word verify that they're inverses, you're composing them each way. Okay, so f of g and g of f, and they should come out to x. If it doesn't come out to x, then they're not inverses. All right, so let's take a look at these ordered pairs here. So is this a function? So look, do any x's repeat? No, no x's repeat, so this is a function. Now, is it one-to-one? Okay, so for it to be one-to-one, basically no x's or y's can repeat. Okay, so if we look, a y value repeats. Okay, so no. Now, is its inverse a function? No. Okay, if we find the inverse of this, it's not going to be a function. So the golden rule of inverse functions, basically. So for a function to have an inverse function. Now the key word is that I said inverse function. Okay? The original must be one-to-one. So to be one-to-one, no x or y values repeat. Also, another thing to think about is basically it passes the vertical line test and the horizontal line test. The original does. Okay. So let's look at a more complex function here. So it says to graph this guy. So rough sketch, this is a quadratic. Hopefully you noticed that because of the fact that it's squared. You could create a table and plot some points, or just think about this takes your graph and moves it up 4. So your standard parabola looks like this. So I'm just going to take that and move it up 4, like so. Okay, so is this one-to-one? No. Okay, so if you think about it, it would pass the vertical line test, but it would fail the horizontal line test. And if you had tables, a table of values, you would see, for example, if you put in 1, you would get out 5. If you would put in -1, you would also get out 5, so the y values repeat. So let's talk about domain and range for a second, and this is going to be important when we get into the trig functions. Okay, the domain of this is all reals, so -infinity to infinity. You can put in whatever you want for x, and you have no issues. Now, when you look at the range, though, notice none of your graph exists down here. So your range is y is greater than or equal to 4. Or if we do it in interval or set notation, 4 to infinity. Okay? So some people look at this and they say, well, if it fails, its inverse isn't a function. Well, we can still find a function's inverse if we restrict the domain of the original. Okay, we only want to focus on half the graph because we want to make sure for this parabola that it passes the vertical and the horizontal line test. So if you think about it, if, side note here, if I have this graph, if this part weren't here, it would pass the vertical and the horizontal line test. Okay, so we only want to focus on half the graph, and we're going to use the vertex, because that's the key point here, the vertex, the top or the bottom, whether it's opening up or down. Okay? That's the key point where we want to restrict it around. So we're going to use the vertex to restrict the graph. So I'm actually going to do a different example down here. Let's do y equals x squared plus 4x minus 12. So we want to be able to restrict this domain. Okay, but first of all, we need to find where the vertex is. So let's do opposite of b over 2a. So opposite of b would be -4. Your a is technically a 1. So my x value is at -2. So to find the y value that goes with that, let's put -2 in for x. So negative 2 squared is 4 plus 8 minus 12. Oh, I copied it wrong. Sorry, that should be a plus. So this should be a minus 8. My bad. Okay, so we should get negative 16. So my vertex is at negative 2, negative 16. Okay, so if you think about this, super, super rough sketch here, we can see it's opening up because the a value is positive. So negative 2, negative 16, like something like this. Like I said, super rough sketch. So we basically want to get rid of this part of the graph so we can focus on this part so that it can be one-to-one. So it passes the vertical and the horizontal line test. So let's restrict our domain. If you think about it, we're restricting it around that vertex, which is at negative 2, negative 16. So we want the x value for the domain to be greater than or equal to negative 2. So in interval or set notation, that would be negative 2 to infinity. For the range, that's the y value, we want y to be greater than or equal to negative 16. So in interval or set notation, negative 16 to infinity for the y values. Now, what if I asked you to find the inverse? So this is how we can restrict the domain. But what if I asked you to find the inverse of this now? Well, so a lot of kids would say, oh, let's switch the x and y like we did before, and then solve for y. But do you know how to solve that for y? And they'll say, well, yeah, factor y out. Well, you can't. Okay, you don't, in your current state, know how to do that. So we're going to do this a slightly different way. Let's think about this. Let's put this quadratic into vertex form. So if you think about it, vertex form, you use your vertex, and you always put in your opposite to that part. Okay, so we're putting this into vertex form. You always put the opposite value in here, and then you leave this part alone. So if I had given you the quadratic in this in this form, you would say that your vertex is negative 2, negative 16. So it's always the opposite goes in here, and the actual value goes here. Okay, so now if you wanted to find the inverse, okay, you would switch your x and y, add 16 over, square root both sides, because you're trying to get y by itself. The square and the square root cancel. Now, normally when you introduce a square root into a problem, you should have the plus and minus, but we don't want both sides to this. Right? Kind of like we didn't want both sides here, you don't want both sides here. Generally, if you keep the right-hand side, which is like the positive side of this, you want the positive side of this. And then subtract the 2. Sorry, I keep forgetting that 1. So now my inverse is the square root of x plus 16 minus 2. Now, think about this. You have a quadratic. It makes sense that the opposite or the inverse of it would be a square root. And let's think about, rough sketch, what this would look like. Now, you're really digging deep here into your Algebra 2 stuff, okay? This is your normal square root graph, okay? And this would take not the vertex, but like the key point there for the square root, and it would move it left 16 and down 2. Think about transformations and what we've been doing here. So once again, super rough sketch. So left 16 down 2 would look something like this. So if you think about this, once again, super rough sketch. The other one looked something like this, negative 2, negative 16. Not the best sketch, but they are symmetric around that line y equals x. Okay, so some kids start to get the hang of this enough that they can say, okay, my vertex would switch to, not vertex, but your key point, negative 16, negative 2. And they say, okay, so this would be a plus 16 in here, and that keeps the regular sign. I don't know if that helps. Some of you are not. If you're not comfortable with the shortcut, please don't do it. Okay, you're going to do some practice from here. And then tomorrow we will get into trig functions and restricting those. Please reach out if you have any questions or you need any help. I hope you are doing well.